Hi everyone, welcome back to Geeks for Geeks. So today we are discussing problem of the day, that is total count. So let's quickly have a look on the problem statement. You are given an array ARR of positive integers and a threshold value k. Okay, so we are basically giving an array and some other value, that is the threshold value k. For each element in the array, divide it into the minimum number of small integers such that each divided integer is less than or equals to k. Okay, so for each element, I can divide that particular element into some small integers, and each element should be less than or equals to the k. What is k? So k is the threshold value that is given to us, right? And also it is given that we have to divide it into the minimum number of small integers, right? So compute the total number of these integers across all the elements of the array, right? So this is the problem statement. So let's quickly have a look on the example to understand the problem clearly. Okay, so this is the example number 1, and the array elements are 5, 8, 10 and 13, right? Also the value of k given is 3. So it means that for every element, I can divide that particular element into small elements, and that element should be less than or equals to k. For example, for 5, in which ways I can divide it? So I can divide it in like 5 ones. So the total sum of the elements should be equal to that particular element. So I can divide it in particular ones, and also I can divide it like 2, 2 and 1, and also I can divide it as 3 comma 2. But can I divide it in 4 comma 1? No, because here the 4 number, it exceeds the value of k, right? But in the question it is given that the value of k is the threshold value for every element of that particular array, right? So I cannot take 4 because 4 is greater than k, right? So for this example, let's see what is the answer. So each number can be expressed as a sum of different number less than or equals to k. So 5 can be expressed as 3 plus 2, because 3 is lesser than or equals to k. Also 2 is lesser than or equals to k. So yes, I can take this configuration for 5. And talking about 8, so 8 I can take it as 3 plus 2, right? Because 3 is lesser than or equals to k. Also 2 is lesser than or equals to k. So I can divide 8 into 3 plus 2. Also talking about 10, so we will be dividing 10 by 3 plus 3 plus 3 plus 1. So here we can see that 3 is lesser than equals to k, and also 1 is lesser than equals to k. And what is the last element? So the last element is 13. So we are dividing 13 by 3 plus 3 plus 3 plus 1, right? So 3 is lesser than equals to k, and also 1 is lesser than or equals to k, right? So here for each element of the given array, I can divide that particular element like this, and every element should be less than or equals to k. This k is the threshold value, right? The total sum of the count of each element. What is the total sum of the count? So here there are 2 elements, here there are 3 elements, here there are 4 elements, and here there are 5 elements. How we are counting? So we are just counting how many elements are there. So 3 and 2, there are 2 elements, that's why we have 2. Here we have 3 elements, so that's why we are having 3. Here we have 4 elements, 3 3 3 and 1. So there are 4 elements, and here we have 5 elements, right? So we have 5 elements. So we have to sum up all these counts. So what is the sum of all these counts? So if we try to calculate the sum, so it will come out to be 14, right? So 14 is the answer for this particular example number, as we can see also. 14 is the answer, right? Similarly, see the example number 2. So 10, 2, 3, 4, 7, and the threshold value is k, that is 4. Each number can be expressed as a sum of different numbers less than or equals to k. So we are dividing 10 as 4, 4, 2. So 4 is lesser than equals to k, right? And we can divide 2 in only one part because it is already lesser than or equals to k. So we don't have to divide, because in the question it is given that we have to find the minimum. So is there any benefit to divide a number which is already lesser than equals to k? No, right? Because we have to find the minimum numbers. So it is better to not divide a number if it is already lesser than or equals to k. And we can see that 3 is also lesser than equals to k. So we should not divide to make our answer to find the minimum answer, right? Also, we cannot divide 4. And for 7, we can divide it as 4 plus 3. So how many total count is there? So we can see that it is 3. So 3, and here it is only one, here it is only one and only one, so 3 plus 1, and in the end I have 2, so 2 elements. So if I try to sum up all these numbers, so it will come out to be 8, right? So that's why 8 is the answer. So I hope this example and problem statement is clear to you. Now let's move to the solution part. Okay, so as we can see that for every particular element I have to divide it into minimum numbers, so that I can sum up all these numbers to make this number again. So for example, 10. So there are many ways to divide 10, but to divide it in minimum numbers, so there will be only one way. Also, we have to keep this thing that every element should be lesser than or equals to 4, right? So why don't we take greedily? So yes, we can take greedily, right? Because I have to find out the minimum numbers. So for example, I have this k equals to 4. So I have removed or subtracted 4 from this 10. So one number is 4. Now what is the remaining number? So remaining number is 6, right? So can I divide 6 again? Yes, because it should be lesser than equals to k. So I have to divide this number. So in how many ways I can divide? So I will move greedily. So I can divide this as 4, and the second part will be 2, right? Because this 4 is, what is this 4? So it is the threshold value. That is the maximum value I can take or I can keep for every element. So from 6, I can divide it by 4 and 2. So what is the total numbers? What is the total count? So we can see that total count is 3. Okay. If the number 2, we can see that number 2 is already lesser than, so the count will be 1 here. 3 is already lesser, count will be 1. 4 is already lesser, count will be 1. And for 7, we will try to divide it greedily. So how we can divide it greedily? So I will take the maximum value from this. So I will take 4 and try to subtract 4 from 7, so the remaining part will be 3. So we can see that 3 is lesser. So yes, I can divide, or I can take this 3 into my answer. So what is the total number of elements? So we can see that there are 2 total number of elements. Now try to sum up these elements. So it will be 3 plus 1 plus 1. So my answer will come up 8. Okay. So basically the idea was to take greedily the numbers or subtract that particular number, divide that particular number greedily. So for example, if I have 8, I will divide, and the value of k is 4. I will try to divide it as 4 comma 4, right? So here the total number of elements will be 2. Okay. So this is the idea that we are going to follow in this approach. How we will be finding the number of elements that we are going to divide that particular. Okay. So for example, if I have 10 and k is equals to 4, right? So how can I find out like how many times k will be coming here in this number 10, so that it is lesser than or equals to the sum? So what can I do is I can divide this 10 by 4. So let's try to divide this 10 by 4. So we will be getting 2, because we know that it will be take the floor value. So it will be around like 2 point something. So in the integer value it will be giving 2. It means that 4 can be added 2 times. 4 can be added 2 times and it will be lesser than or equals to 10. So now, so what is the remaining value? So the remaining value will be 2. So it will be lesser than, it will not be greater than, right? Because let's try to find the remainder here. So how we can find the remainder? So we will find the remainder by doing modulo operation. So 10 modulo 2, 10 modulo 4, it will give me 2. So what is this value 2? It is lesser than this value, right? So if I try to find out how many times that number can be added and it is lesser than or equals to k, uh, it is lesser than or equals to that particular array of I. So I will find, or I will divide that particular element by k. I will get some value uh, in which how many times I can add that particular element, so that it is lesser than or equals to the array of I value. Also, what is the last value, or if it is not divisible, here we can see that 10 and 4. So if I try to find out the value, here comes out to be 2. So add 4 2 times, so it is 8, right? What about the remaining value? I want my total sum as 10, right? But I am only getting 8. So the remaining value, what is the remaining value? So the remaining value is 2. So this remaining value 2 will be always lesser than k. So for this particular element, how can I find out? If array of I modulo k is equals to 0, it means that that array of I is completely divisible by k. Then there is no need to take one extra number, because this extra number will only be taken when it is not divisible. So for example, if we are given array of I as 12 and k value as 4, so you can see that you can find out how many times you can add 4 to get the value lesser than equals to k. So you will be getting 3. So divide 12 by 4. So 12 divided by 4, it will give you answer as 3. So if you try to add 4 plus 4 3 times, so it will give you 12. So there is no need to add some extra value. Here we will be adding one extra value because it is not divisible, right? So how many total elements I will be getting? So 4 plus 4 plus 2. So there are 3 total elements, right? How we can get? We can say that array of I divided by k will give me the value for these numbers, and if after that, if that particular element is not divisible, so I will be adding the plus 1 for this last element. Okay, let's try to write the pseudocode. So answer 0, and we will be iterating on our array from 0 to n minus 1, and if array of I is completely divisible by k, then we can say that we will not be needing uh, this last element or this last value, because it is completely divisible. So just add array of I divided by k into my answer variable. Okay, else we have to add array of I divided by k and also a plus 1. Why plus 1? We have discussed that we will be adding plus 1 for this remaining element, that is 2 here. So add a plus 1 also. Okay, so this is the pseudocode, and let's try to see how it is working for this particular example number 1. Okay, so we have array like this, and we will be having answer as 0 initially. I is at the very first element, that is 5, right? So now check if array of I is divisible by k or not. So we can see that 5 modulo 3 is not coming out to be 0. So we will be going into our else part. So what is the else part? So it is array of I divided by k. So divide 5 by 3. So it will give you 1. And also we have to add a plus 1 because of this remaining element. So now my answer will become 2 after the first iteration. Now coming to this second iteration. So the value here is 8. So we can see that 8 modulo 3 is also not equals to 0. So divide 8 by 3. So it will be coming out to be 2, and also add a plus 1 because we will be going to our else part. Answer will become 5. 2 plus 3. Now we can see that 10 modulo 3 is not equals to 0. So 10 by 3, it will be I guess 3, and we will be going in our else part. So 3 plus 1, that is 4. So I will add 4 to my 5. So it will become 9. And at the very last element, so it is 13. So try to divide 13 by 3. So we will be getting some remainder. It means that it is not divisible. So just go to the else part and find out 13 divided by 3. So it will give you 4, and also add a plus 1 because of the remaining part. So 9 plus 5, it will be giving 14. Okay, so that's how our answer will come up as 14. So now let's try to code this. So we will be taking one answer variable which will be storing our answer, and we will be iterating on our array if the particular element at which we are current. So if element modulo k equals to 0, it means that particular element is divisible. So there is no need to add a plus 1. So we will just simply doing array of I or element divide by k. It will give me the minimum number of elements in which I can divide that particular element, and it should be less than or equals to k. Else I will add a plus 1 in this thing, plus 1, right? So this is the for loop, and in the end just simply return the answer variable. Okay, let's try to compile and run this. Okay, so it is giving some error. Okay, so at line 20 I have to divide this by k, right? So now let's try to compile again. Okay, so yeah, it's passing for the visible test cases. Now let's try to submit. Okay, so it is also passing for the hidden test cases, right? Now let's talk about the time complexity. So here we can see that we are iterating on our array by one. So the time complexity here would be big O of n, and also we are not taking some extra space. So space complexity would be constant, right? So time complexity is big O of n and the space complexity is constant. I hope this problem is clear to you. So if you find this video helpful, then drop a like and also subscribe to the channel. Thank you for watching this video.